Hi students, welcome to this video session. My name is Samuel Chukwuemeka. In this video session we shall discuss complex numbers. Please, before you view this video, it is recommended that you view the videos on numbers that I did, the video on numbers, as well as the video on radicals. The video on radicals, it is important that you view these two videos prior to viewing this one. Numbers are a lot. You know, when we talked about numbers, we talked about whole numbers, prime numbers, rational numbers, irrational numbers, real numbers, integers, and the rest of them. Then on the last part, we discussed complex numbers. We talked about complex numbers. Now, not all numbers are real numbers. Some numbers are complex numbers. Okay, but the thing about it is that you can write any real number as a complex number, but you cannot write any complex number as a real number. Okay, in other words, all real numbers can be written as complex numbers, but not all complex numbers can be written as real numbers. We shall talk about it as we move on in this video. Okay, assuming if we can recall, if I ask you the square root of 16, okay, if I ask you the square root of 16, you will tell me that it is a plus or minus 4. Okay, it is plus or minus 4 because 4 times 4 will give you 16. Negative 4 times negative 4 will also give you 16. So, by the principal square root, if I ask you the principal square root of 16, you will now tell me that it's 4. Okay, so in real numbers, you know, we have 2 square roots. Okay, now, what if I ask you this? What if I ask you the square root of negative 16? If I ask you the square root of negative 16, what will you answer? Try putting this in the calculator. Try putting square root of negative 16 in the calculator, and you will see it will give you E. Okay, E meaning error. Some calculators will write E, some calculators will write error. Okay, this is not an error. Now, beyond real numbers, especially in engineering applications, for some of you that are engineering majors, okay, and some scientific applications as well, we encounter the use of complex numbers. Okay, now we can still solve this to mean that square root of negative 16, we could solve it to mean square root of negative 1 times square root of 16. When we apply the law of radicals, okay, when we apply the law of radicals, we can write that square root of negative 16 is equal to square root of negative 1 times square root of 16. Remember, the law of radicals tells us that square root of AB is equal to square root of A times square root of B, and vice versa. Vice versa, meaning that when you have square root of A times square root of B, it will give you square root of A times B, and that is square root of AB. So, in that case, we can have that negative 16 means negative 1 times 16. Okay? So, this will now be, we now define this as what we call I times 4. 4 being the principal square root. Okay? Now, in this video, for all real numbers, we shall only be dealing with the principal square roots. Okay? For all the square root of real numbers, we shall only be dealing with the principal square root, which is the positive square root. And this will now give us 4i. Some textbooks will write it as j. In some mathematical textbooks, you see it as j. It's the same thing. So we now see that square root of negative 16 is equal to 4i. And that now brings us to what we call complex numbers. Because you will not ask me, what is I? That is the next question you will ask me. What is I? Okay, so this brings us to now the study of complex numbers. So we say that complex numbers, the simple definition is that are the square roots of negative numbers. Okay? We can define it as the square root of negative numbers. Yeah. Now, basically, we have three forms, three forms of representing complex numbers. We can represent complex numbers. We can represent complex numbers in three forms. Okay? We can represent complex numbers in standard form. We can represent them in polar form of a complex number, and then we can represent them in the exponential form. So these are the three forms that we can represent complex numbers. Okay, for other majors, for science and engineering students, especially engineering students and mathematics majors, you probably will still learn polar form and exponential form of complex numbers. But for just this pre-calculus algebra, we are going to deal with only the standard form of a complex number. And then we can kind of explain it very well as we do it. Okay, so the standard form of a complex number, is written as A plus BI. Like I said, some textbooks might have it as X plus YJ. Okay, where J is the imaginary unit. Okay, but here I'm going to use A plus BI, where we have that A and B where A and B are real numbers. A and B are real numbers. Now we know that real numbers are any numbers that exist on the real plane. Okay, real numbers are any numbers that exist on the real plane. They include rational numbers. They include integers, whole numbers, fractions, decimals. They include all these. Now, so A and B are real numbers. Then A is what we call the real part of the complex number. Real part of the complex number. Okay? And then B is what we call the imaginary part. Okay? A and B are real numbers, but A is called the real part of the complex number, and B is called the imaginary part of the complex number. Then I is known as the imaginary unit. Imaginary unit. Okay. BI is known as the pure imaginary number. Pure imaginary number. Okay, so this is the standard form of a complex number as this, A plus BI. So if I have something like this, let's look at some examples now. Let's look at some examples. If I have something like 2 plus 5i, Okay, you see that A here, if you compare it with A plus BI, you see that A is 2, okay, A is 2, and then B is 5. Okay, so 2 and 5, they are all real numbers, they are whole numbers. Okay, now, and then the real part is 2, the real part, that is A, is 2, and the imaginary part B is 5. Imaginary part is 5. Now, I don't want you to get confused. A and B are real numbers, but A is called the real part. A is called the real part, and B is called the imaginary part. Just take note of that. No? Yeah. And then, just any time they write a complex number and they ask you for the real part and the imaginary part, you just express it in the standard form and then you write it. Okay? Let's do some more examples before we go to powers of I. Okay? If I ask you to, if I have -2 plus 10i, and I ask you what is the real part, what is the imaginary part? Here, A is -2, and then B is 10. Because remember, you always have to compare it to A plus BI. You always have to compare it to A plus BI. You see that A is -2, and then B is 10. Now, what if I have this? What if I have -2? Just -2. This is a real number, right? What if I have just -2? That's a real number. And I ask you, what is the real part and the imaginary part of the complex number? Okay, like I said earlier, you can write every real number as a complex number. Yeah, but you cannot write every complex number as a real number. Now, this is a real number. This means -2 plus 0i. Remember, we always have to put it in this form, A plus BI. This is the standard form. So, when we have -2, it means -2 plus 0i. Okay? And in this case, the real part, A, is -2, and the imaginary part is 0. So you see, this is a real number, and I have written it as a complex number. And I have found the real part and the imaginary part. Alright, what if we have, let's look at another example. What if we have -2 minus 10i? In this case, it's still the same thing. Our A is what? -2, and our B is what? -10. Why? Because you can write this as A plus BI. And if you do that, this will be -2 plus -10i. So this is kind of A being -2 and then being -10. Because -2 minus 10i means -2 plus minus 10i. So this plus is this plus. A is -2 and then B is -10. Okay, another example. What if I have 7i? If I have only 7i, and I ask you to find the real part and the complex part. Now, 7i is a pure imaginary number. Remember, we say that BI is a pure imaginary number. Okay? Now, this is a complex number. Right? It's a complex number. I mean, it's not a real number. It's a complex number. But you are asked to find the real part and the imaginary part. So what do you think will be the real part? Remember, you want to put it as A plus BI. So what do you think you have to put as the real part? This means 0 plus 7i. That is what it means. And when you put it in this case and compare it to this, you see that the real part is 0 and the imaginary part is 7. Okay? What if we have -12i? Okay, this means what? 0 minus 12i, and that means 0 plus minus 12i. So you compare it with A plus bi. When you compare it, a is 0 and then b is minus 12 or negative 12. It's the same thing. So all real numbers, we can write it as complex numbers. But all complex numbers, they are not real numbers. No way. They are not. Complex numbers cannot be real numbers. You can't write them as real numbers. You can only write them as the standard form of a complex number. But you can't remove this I, the imaginary unit. You cannot remove it. But if it was just a real number, then you can put plus 0i, you know. Yeah. With a real number, there is no I. That I makes it a complex number. Okay? So, let's go to powers of I. Okay? Let's go to powers of I, and then we can revisit this again before we solve these questions and we finish part 1. Alright, now let's go to powers of I. Powers of I. Let me write it. Powers of I. Now, we see that I, by definition, I is square root of negative 1. By definition, I is square root of negative 1. Okay? So, square root of a negative 1 is I. So that means that when we have the square root of any negative number, we can express it in terms of I. Okay? We're coming to that. Now, that means I squared will be square root of negative 1 all squared. I squared is going to be square root of negative 1 all squared. And that will give you negative 1. Now, I want you to note this. Because if you can recall when we did radicals, okay, and the operations on radicals, square root of negative 3 all squared gives you 3. Square root of 5 all squared gives you 5. Square root of Mr. C all squared gives you Mr. C. Okay? Square root of sum done for peace all squared gives you sum done for peace. Okay, so now I squared is square root of negative 1 all squared, which is negative 1. Okay? Now, please, note this. Note, and I'm still going to come to this. I squared is not, when you do square root of negative 1, because some students tend to get confused here. They might write it as square root of negative 1 times square root of negative 1, and then they will write it as square root of negative 1 times negative 1, and they will write it as square root of 1, which is 1. Because negative 1 times negative 1 is 1, which is 1. Okay. This is what I'm going to mention as we go on in this video. For complex numbers, please and please, when you see a negative square root, we express that first and foremost in terms of I. That is the rule. Before any of these rules apply, because when we start solving this question, you will see what I'm talking about. Okay, like question 9, square root of negative 16 times square root of negative 4. Some students might write it square root of negative 16 times negative 4, and then square root of 64, which is 8. That is wrong. When we have complex numbers, we don't want to come and apply this method, whereby you do square root of negative 1 times negative 1. That you apply this law, that square root of AB equal to square root of A times B, which is square root of A times square root of B. Okay, For complex numbers, this won't work with where A and B are less than 0. That's where A and B are. This won't work where A and B are less than 0 for complex numbers. That is for negative numbers. No, we don't want to use that for complex numbers. So this is something that is a bit confusing, but you should just don't bother about it. Okay? For complex numbers, just know that we won't apply this law first. We have to apply the law of expressing any square root of negative number in terms of I first. We don't want to come and apply this law of radicals here. Okay? This will only apply here for where A and B are not negative. Square root of any negative number, the first and foremost rule is to express it as I. That I is square root of negative 1. Okay? So we won't use this at all. We're not going to use this. So take note of that so that you don't get confused here. It's a common confusion for students. Okay, now I squared will be negative 1, then I cubed will be I squared times I, which is negative 1 times I, which is negative I. I cubed is negative 1 times I, which is negative I. Then I raised to the power 4 will be I squared times I squared, okay, which is negative 1 times negative 1, which is 1. So these are the basic things here. These are the basic things we need. We can now evaluate other powers of I based on this. And I'm going to show you the easy way of doing it. Easy way of doing it. Okay? So let's go ahead. We already know this, so let's go ahead and evaluate other powers of I. Let's evaluate other powers of I. So we have I is square root of negative 1. So I squared will be, we say is negative 1. I cubed, we say is negative I. I4, we say is 1. Okay? Now, I5, what do you think I5 will be? What do you think I5 will be? I5 will be I4 times I. Okay? Now, let me tell you this. It is good, any other powers of I after I4, express it in 4. Because you want to work with 1 or negative 1. You don't want to work with negative I. No. Okay? Any other high powers beyond 4, express it with 4. It's easier in terms of 4. Express this in multiples of 4 and then apply your laws of exponents. It is easier that way. Okay? So this is I5, we express it in 4. Just like laws of exponents, 4 plus 1 is 5. Because this means I raised to power 1, which is I. So this will now be 1 times I, which is I. So I5 is I. Let me write it here. I5 is I. Now I6 will be I4 times I squared. Okay, I4 times I squared is I6, which is 1 times negative 1. Okay, and that is what? Negative 1. So, you know what? Let me write this here. So, we see that I5 is I, I6 is negative 1. So, this means I5 is I, I6, negative 1. I7, we express it in powers of 4. This means I4 times I cubed. Because 4 makes it easier for us. So any other high powers, we want to express it in powers of 4. So this will be 1 times I cubed is negative I. So which is negative I. So I7 is negative I. Then I8, what do you think I8 will be? I8 will be I4 times I4. Okay? Which is 1 times 1, which is 1. So I raised to power 8 will be 1. I raised to power 9, what do you think I raised to power 9 will be? It will be what? I raised to power 9, you can express it with I4. This means I4 all squared times I. Okay, remember your laws of exponent. That's good. You need to view the laws. You need to view my videos on exponents. Yeah. This means I4 all squared times I, because 4 times 2, 8, plus 1, 9. So this is 1 squared times I, and that is 1 times I, which is I. So I raised to power 9 is I. Then I raised to power 10 will be what? I10 will be I4 all squared times I squared. So that is 1 squared times negative 1, which is negative 1. Okay, 1 times negative 1, negative 1. Okay, I11, what do you think I11 will be? It's going to be negative I. Then I12 will be 1. And so it continues. So when they ask you, so assuming they ask you now, let's say they ask you to find I22. Let's say they ask you to find I22. I raised to power 22. Right? So all you need to do is you know how many 4s. You ask yourself, how many 4s are in 22? 5 4s. Remember, 2. So this will be I4 all 5 times I squared. Okay? Because 4 times 5 is 20. 20 plus 2, 22. So this will be 1 raised to power 5 times I squared is negative 1. 1 raised to power 5 is 1 times negative 1. And I22 is negative 1. That's as simple as that. If there are any number of I they ask, even if they ask I320, I375, okay, just find how many 4s are in there and put it like that. Even if they ask 1 over I75, what if they ask 1 over I75? Okay, this, excuse me, this will be 1 over I4. How many 4s are in 75? Okay, this is a 4. Then 35 is 8. Okay, 18 4s times what? 4 times 8 is 32, 72 plus 3, 75. Okay, so this means 1 over 1 times negative I, and that is 1 over negative I. Now, when we come, when we come to rationalization, we can still work this out. Okay, this means negative 1 over I times I over I, which is negative I over I squared, which is negative I over negative 1, which is I. Yeah, but you probably don't understand what I did, rationalization. But later on we can talk about it. Yeah, but no matter what they ask, for you to find in terms of I, you just have to do it right. Okay, even if they ask, they might ask negative I, negative 45. I raised to power negative 45. Now you want to deal with only positive exponents, so you use the law of exponents. When you use the law of exponents, you have 1 over I raised to power 45, and that will be 1 over I raised to power 4. How many 4s are in 45? 11 times I, okay, which is 1 over 1 times I, which is 1 over I. Then 1 over I, you probably want to rationalize it, and if you do, it will be I over I squared, which is I over negative 1, which is negative I. Now, don't you worry about this. We shall still do rationalization to show you how we got this. Yeah. Okay? So that's kind of how we do powers of I. Right? So, okay, let's go to the next thing we want to discuss before we solve these questions on the board. Let's go back to the standard form of a complex number, a plus bi. Right? Now, if a is 0, that means you now have what? 0 plus bi, which is only bi. So when a is 0, you only have a pure imaginary number. Pure imaginary number. Okay? When a is 0. Now then, what if b is 0? Assuming b is 0, then you now have a plus 0i. And that will give you what? A. And that will give you a real number. So what does this tell you now? That every real number is a subset of a complex number. So real numbers are subsets of complex numbers. But complex numbers are not subsets of real numbers. That's what it tells you. Okay? Real numbers are subsets of complex numbers. Okay? Alright. Let's now solve some questions and then we call it a day. Okay, number one. Like I mentioned earlier, when you want to find the square root of a negative number, you must express it in terms of I. Must. Yes, you must do that. Express it in terms of I. So when we have square root of negative 64, this gives us square root of negative 1 times square root of 64. Okay, and we are interested in with the positive square root of 64. That is what we are interested in. We're not interested with the we're interested with the positive square root, not the negative square root. That's why we're interested in the principal square root of 64. So this will be I times 8. And that will give you 8i. The answer is 8i. Now let me point this out. Just like you have in real numbers, square root of 64 is plus or minus 8, right? You can also have that in complex numbers. The square root of negative 1 is plus or minus I. Okay, but we are not interested in here, like I said, we're only interested in I. We're only interested in I, but you also can have, you can also argue that in complex numbers that the square root of a negative number has 2 roots. You can argue that. Okay? But in this video we're interested in just the principal square root. Okay? So we're interested in I being square root of negative 1. And like I mentioned earlier, when you have the square root of a negative number, you must express it in terms of I. You must do that. Okay, so the answer is 8i for number 1. Okay, let's finish the rest. Square root of negative 17. Okay, this means what? Square root of negative 1 times square root of 17. Okay, so this is I times square root of 17. You can't simplify this. You cannot simplify the radical, so the answer will be I square root of 17. The answer will be I square root of 17. Please take note. Don't write it. Please don't write it like this. Square root of 17I. Just write I square root of 17. Write like this. Don't write like this. No. Because you might be tempted. You might be tempted to write, if you write like this, you might be tempted to write square root of 17I. And that is messed up. That's wrong. Okay? So we want you to write the I first times the radical. Now, but when we have the I and then a real number, when we have the I and and an integer, you write the integer first. Like when we have 8, instead of us I times 8, we say 8I. We don't want to say I8. No. We want to say 8I. But when we have I times square root of 17, we want to say I square root of 17. We don't want to say square root of 17I. No, we don't want it. So when we have integers, write the integer first before the I. And then when you have radicals, write the I first before the radical. Okay? Then, the next one, square root of negative 25 over 36. So, the first thing we have to, when we have negative square root, we bring up negative 1 first. I. Negative 1, square root of negative 1 times square root of 25 over 36. So this will give us I times 5 over 6. So this will be 5I over 6. The same thing when you have fractions. When you have fractions also, write a fraction before the I. When you have fractions, you write it before the I. Okay? Next one, square root of negative 32. When we have square root of negative 32, this means square root of negative 1 times square root of 32. So this means I times, you can simplify this. Please, I did videos on simplifying radicals. I did videos on radicals. And also adding and subtracting radicals. I did videos on that. So you can simplify this. And I talked about how you can simplify it there. So this is 16 times 2, which is I times square root of 16 times square root of 2, which is I times 4 times square root of 2, which is 4I square root of 2. 4I square root of 2. Yeah. How you can simplify radicals. I talked about it in the video, so view it. Okay, and it's on my website. Square root of negative 150. Square root of negative 150. So this means square root of negative 1 times square root of 150. So this is I times square root of 25 and 6. 25 and 6, which is I times square root of 25 times square root of 6, which is I times 5 times square root of 6, which is 5I square root of 6. 5I square root of 6. Then the next one, 5 square root of negative 28. So this means, don't be scared about this. We will do it the same way. This means 5 times square root of negative 28. That's what it means. So it means 5 times square root of negative 1 times square root of 28. So this means 5 times I times 28. Can we simplify it? 2 and 14 will not work. Yeah, 4 and 7 we can. 4 square root of 4 times square root of 7. So 5 times I times 2 times square root of 7, which is 10I square root of 7. 10I square root of 7. Okay? The next one. Please, with the way for my videos, it's good. Before I do the next one, you pause. Before I solve any question, the next question, pause it, solve it on your own, and if after solving it, you can now play it and see whether we get the same thing. Okay? Next one, negative 7 square root of negative 80. So this will be negative 7 times square root of negative 80, which is negative 7 times square root of negative 1 times square root of 80, which is negative 7 times I times square root of 80, 4 and 20. But we still have 16 and 5. So we choose 16 and 5. Square root of 16 times square root of 5. So this is negative 7 times I times 4 times square root of 5. So this is negative 28I square root of 5. Negative 28I square root of 5. Okay? We all want to express all this in terms of I. The next one, 15 square root of negative 90, right? This means 15 times square root of negative 90, which means 15 times square root of negative 1 times square root of 90, which means 15 times I times 90. 4 will not go. The next one, 1, 4, 9, 9 and 10. 9 and 10 will work. 9 and 10 will work. 9. Square root of 9 times square root of 10. So this is 15 times I times 3 times square root of 10, which is 45I square root of 10. Okay? 45I square root of 10. Okay, let's finish up. We still have some more. The next one, square root of negative 16 square root of negative 4. Okay, please listen up. Now, some students might be tempted to do it the other way. They might say, okay, law of cells, maybe square root of AB to the square root of A times B. They might now do square root of negative 16 times square root of negative 4, which is square root of 64, which is A. Wrong. Now, for these complex numbers, wrong. Now, when we are solving square root of a negative number, which means complex numbers, we have to apply a rule that states that anytime there is a square root of a negative number, it must be expressed as a complex number. That rule first. So we've got to express any square root of a negative number as a complex number first. That's the first rule we have to express. So this square root of negative 16, this means square root of negative 1 times square root of 16, then times square root of negative 1 times square root of 4. That is what it means. So this means I times 4 times I times 2. Okay? 4 times 2, let's deal with the integers first. 4 times 2 is 8 times I squared, which is 8 times negative 1, because I squared, we got negative 1, which is negative 8. So the answer is negative 8. Please, it is very important. Now, if you were to write this as a complex number, it will be negative 8 plus 0I. If you were to write it in standard form of a complex number, it will be negative 8 plus 0I, just like we demonstrated earlier. Okay, but the answer is negative 8. And the question, it wants you to write in terms of I first before you simplify. Okay, so that's the way we do this. Other ones, square root of negative 5 times square root of negative 15. So this means square root of negative 1 times square root of 5 times square root of negative 1 times square root of 15. Okay? So this will be I times square root of 5 times I times, now square root of 15, if we look at this, it doesn't have any perfect square. It does not. You know, you can actually simplify square root of 15. But because you saw square root of 5 here, something can work. Something can work. So when you break it down in 5s, you have square root of 5 times square root of 3. Okay? And this will now be I squared times 5, because square root of 5 times square root of 5 is 5, times square root of 3. So this is negative 1 times 5 times square root of 3, which is negative 5 square root of 3. Okay? Negative 5 square root of 3. Okay. The next one, we have square root of 6 times square root of negative 8. So this means square root of 6 times square root of negative 1 times square root of 8. Okay. We look at 6 and 8. We can have 6 and 8 to be 48. And then we can, you know, you can do this like this. You can even do 5 times 15 to give you 75. And then you do 25 and 3. You can do that. Okay? You can do 5 times 15 to give you square root of 75. And then you simplify 75 to give you 25 and 3. Okay? The same thing. That's what we can do here. So this means square root of 6 times square root of 8 times I. So this means square root of 48 times I. Square root of 48, we can use 4 and 12. But with 4 and 12, we can use 16 and 3, which is better. So this means square root of 16 times square root of 3 times I, which is 4I square root of 3. Because that's 4 times square root of 3 times I, which is 4I square root of 3. So you keep simplifying. That video that I did on radicals will help you. You need to view it. You really need to view it. I'm gonna tell you how you can view it when I finish. Okay, the next one, we have square root of negative 25 over square root of negative 36. So this will be square root of negative 1 times square root of 25, okay, all over square root of negative 1 times square root of 36, okay. So this will be I times 5 over I times 6. Of course, I will cancel I. You have 5 over 6. 5I over 6I. I will cross out I and you have 5 over 6. Okay? The next one, second to the last, we have square root of negative 63 over square root of negative 7. So this will be square root of negative 1 times square root of 63 over square root of negative 1 times square root of 7. Right? Now, here you can now do your, here actually you can do your radical sign. Because you look at 63, you look at 7. 63 divided by 7 is 9. You can go ahead and divide it. Okay? This means I over I times square root of 63 over 7. You can do it that way. So I and I is gone. So this is what? Square root of 9, and that will give you 3. Okay? Yeah, because you can't simplify square root of 7, and even for, well, 63 you can. Another way you can do it is to do 9 times 7. You know, there's another way you can do this. 9 times 7. Let me show you another way you can do this question. There are so many ways you can do it. Okay, you can do this from here, where you have I times square root of 63 over I times square root of 7. You can divide I, then you have square root of 9 times 7 over square root of 7, which is square root of 9 times square root of 7 over square root of 7. Square root of 7 can cancel square root of 7. I have square root of 9 which is 3. You can do it that way. Okay, the last question. Last question is square root of negative 24 over square root of 6. So this means square root of negative 1 times square root of 24 all over square root of 6. So you can do I times, you can go ahead and do, if you want, you do square root of 4 times square root of 6 over square root of 6, and then you cancel this, and it will be I square root of 4, which is I times 2, which is 2I. But if you don't want to do it this way, you can go ahead and do from here. If you don't want to do it this way, you can go ahead and do square root of negative 1 times square root of 24 over square root of 6. You can do I times square root of 24 over 6, which is I times square root of 4, which is I times 2, which is 2I. You can also do it this way. You can. Yeah. Okay. Please, we've come to the end of this first part. Complex numbers is a bit big on what we have to cover. When you go to my website, samuelchukwuemeka.com. Then you click on my picture. You click on my picture to enter the site. Then you click on mathematics. You click on math. You click on my picture to enter the site. You click on mathematics. Okay. Then you click on I think the radicals I did, I think is in arithmetic. Yeah. I think it's in arithmetic. You click on arithmetic. And then you click on roots. You look at roots and radicals. Roots and radicals. Yeah. Okay. Now after viewing it, well, when we come to addition of complex numbers, you might need to know how to add and subtract radicals. That one is under algebra. Okay. Yeah. But this will kind of get you done with this, so that you can have an understanding how we did from 9, actually from